Hello everyone, this is Miss Barber with lesson 5.9 part 1 in Algebra 2, Operations with Complex Numbers. So in lesson 5.5, we learned about what complex numbers are, how they have a real part and an imaginary part. When graphing it, you always just graph the real part, the first part, on your x-axis, and then the imaginary part you'll graph on your y-axis. So for example, the point negative, this point here is 2 minus 3i. That's like graphing the point positive 2, negative 3. Because your real is positive 2 on the x, and your imaginary is negative 3 on the y. So that's how you graph complex numbers. Now, to find the absolute value of a complex number, you're going to use this formula of the absolute value of a plus bi will just be a squared plus b squared square rooted. And that should look familiar to you because it's a Pythagorean theorem with your a and your b. So let's try a few together. For number 1, they want us to graph and label each complex number. My real part is 1, so I'm going to graph 1 on my x-axis. My imaginary is 1i, so I'm going to graph the point 1, 1. So I'm going to go right 1, up 1, and that will be my point 1. Number 2, I have no real part. There is no part without an I, so that will be 0. And my real part is 4. So I'm going to graph the point 0, 4. So nothing left, right on my real axis and 4 on my imaginary. And this is number 2. For number 3, I don't have an imaginary part. So my real part's negative 2. My imaginary part's 0, so I'm just going to graph negative 2. So you can pause the video and try numbers 4 and 5. Again, your real part will be your x-axis, your imaginary part will be your y. Now, for finding the absolute value, for each you're just going to have to identify your a and your b, or your real part and your imaginary part without the I, square them, and then take the square root. In number 6, I don't have a real part. So my a would be 0, and my imaginary part would be negative 8. So I'm going to do the square root of 0 squared, substituting 0 in for a, plus negative 8 squared in for b. You could put that in your calculator or simplify in your head, but when you do that, you're going to get your answer to be 8. Remember, this is absolute value, so all of your answers should be positive. Just like with solving the quadratic formula, you want to put whatever underneath the square root in first, just in case it's not a perfect square, so then that way you can simplify and not get decimal answers. Number 2, my real part is 2, and my imaginary part is 1i. So I'm going to do the square root of 2 squared plus 1 squared. Again, only putting the underneath the square root in the calculator, that's going to end up being 4. So I'm going to get the square root of 5 for my absolute value. Now you could also get the decimal answer, but that's not necessarily what we want. A lot of times we just like to keep it as a simplified square root. Number 8, my real part is 3. My imaginary part doesn't exist, so it's going to be 0. Well, we already know the absolute value of 3 is 3, so applying the formula, we should also get that. I'm going to take the square root of 3 squared plus 0 squared, and that's going to end up being 3, just as predicted. So that's how you do all of these problems. We'll try one more together, and then you'll be on your own for the last 2. So for number 9, my a is 5. And my b is negative 2. My imaginary part has a negative 2. So underneath my square root, I'm going to have 5 squared plus negative 2 squared. 5 squared plus negative 2 squared ends up being 29. 29 can't be simplified, so I'll just leave my answer as the square root of 29. So that's how you find the absolute value of a complex number. Now for adding or subtracting. To add or subtract complex numbers, you're just going to add the real parts and add the imaginary parts. Think of it as combining like terms. When you're multiplying, you're going to multiply just like you did with quadratics, so you can use the distributive property. One thing that's very important to remember is that I squared is going to be equal to -1. So whenever you get an I times I, that's going to end up being I squared, that you'll then substitute -1 in. Basically, you're going to change the sign. If whatever's being multiplied by I squared is positive, it'll become negative. If it was negative, it would become positive. So for all of these, you're going to add or subtract. So it's just like combining like terms. In number 12, this is all addition, so the parentheses don't matter. I have a 6 and a 3. When I add those together, I get 9. And then my imaginary parts, I have I and minus 2i. Well, I minus 2i will just be minus I. So that's all you have to do. For number 13, I have a minus that I have to distribute to inside my parentheses. So I'm going to rewrite it as 9 minus 3i minus 2 minus I, distributing that negative. Combining like terms, I have a 9 and a minus 2, which is going to be 7. And then I have minus 3i minus I. So that will become minus 4i, combining like terms with the coefficients. So that's how you add and subtract. We can try one more. Let's try 15. I have a negative again. I'm subtracting that I have to distribute. So I'm going to get 1 minus 7i minus 1 plus 5i. Minus minus becomes a plus. 1 minus 1 becomes 0. So I don't even have to write it. And then minus 7i plus 5i is going to be minus 2i. So that will be your final answer. So that's how you add and subtract. Just combine your like terms, your real with your real, your imaginary with your imaginary. Now for multiplying. You're going to do it the same way you did quadratic. So if you like to do the box method, use the box method. If you just like to use distribution, use distribution. The one thing you have to be careful of is when you get I squared at the end. So looking at number 17, I'm first going to multiply 3 by 2 and get 6, then 3 by 2i to get 6i, then I by 2 to get 2i, and then I by 2i to get 2i squared. Remember, I squared is the same thing as -1. So if I substituted -1 in for I squared, my positive 2 would become a -2. So I would have my same 6. I could combine 6i and 2i to become 8i. And now my 2i squared would become -2. I still have one more thing I can combine. I can combine my 6 and -2. They're like terms. And I'm going to end up with 4 plus 8i. And then that's as combined as it can be. So that's how you multiply complex numbers. So let's try number 18 next. I only have one thing out in front, the 5i, so I'm going to distribute it to both things inside parentheses. 5i times 4 will be 20i. 5i times 3i will be plus 15i squared. Remember, I squared is exactly like -1. It's going to change the sign of 15 to become negative. So now it's going to be 20i minus 15. Complex numbers we normally write with the real part first. So I'm just going to rearrange this as to -15 plus 20i, and that will be my final answer. Because we always write our real part first and our imaginary part second. That's just customary. So that's how you multiply. Let's go ahead and just quickly look at number 20, so then that way we're all good with that. Remember, this square means I'm actually multiplying 2 plus 4i by itself. So you can't just distribute the 2 inside parentheses. You have to rewrite it as 2 binomials that then you can distribute. So you would do 2 times 2 to get 4, 2 times 4i to get 8i. Doing the same at the top, I'd get 8i again. And then 4 times 4i would be plus 16i squared. Again, I squared is the same thing as negative 1. It's going to change my 16 to become a negative. So I'm going to be left with 4 plus 8i, and 8i is 16i. And this is going to be minus 16. Lastly, combining 4 and minus 16, I'm going to get negative 12 plus 16i. So that's part 1 of lesson 5.9. Part 2, which you'll do tomorrow or later today,